Hello everybody and welcome back. We're looking at B4 from our 2012 Open Contest. And what have we got here? In the following diagram, two lines that meet at point A are tangent to a circle at points B and C. The line parallel to AC passing through B meets the circle again at D. Join the segments CD and AD. Across this way and up across the circle this way. Suppose AB is 49. Well, that would make AC 49, which they don't tell us, but we'll get into that in a moment. So AB is 49 and CD is 28. The length of AD is a positive integer n. We need to figure out what this n is. Okay. So just off the top of my head, point outside a circle, and we're talking about lengths, specifically this length here, connecting a point outside a circle to a point on the circle. I'm thinking power of a point theorem. Okay, so power of a point, if you have a circle here, and you have some point off the circle, and a chord through that circle is extended and it goes through P, we call these X and Y, and maybe you have a different chord that also extended through the circle hits P, maybe call these W and Z, then it turns out there's a nice little constant. Px times Py is the same as Pz times Pw. And this even works for tangent points. So I had a tangent line here. There aren't 2 points to use, so you just double up on the length Pt. So this is a nice constant. It changes no matter where. It changes based on where the point is. It's a function of both the point and the circle. But there's this nice constant, and this is one of the reasons I know that AB, that's a tangent line, and AC, that's a tangent line. So if one of them's 49, the other one's 49. This also makes me think that maybe if we added in, say, a point here, E, if we could figure out AE, well, AE times AD has to be AB squared, which would be 49 squared. Okay, so that's definitely something to think about. So that gives us options. Do I actually need to figure out AD, or could I figure out AE? Okay? And, you know, there might be ways to figure out AE that are easier. Nothing immediately is coming to mind. So while I mill this over in my head, I'm going to redraw the picture, but a little bigger. So we've got AC, we've got a nice tangent here. Put C right at the bottom there. And we'll put B right here, and so BD is parallel. I want to use the parallel somewhere, because otherwise why did they give us the parallel? The fact that those lines are parallel. And we want to figure out AD, or potentially AE. Oh, and they also gave us CD is 28. So I'd like to use that 28. We got both of these 49s here. So the question is, where might we go from here? And usually when I see tangent points, I think perhaps we should connect them up with, say, the center of the circle. So let's call the center here O. The radius to the tangent point is a nice right angle to the line, to the tangent line. So a nice little right angle there. And, So I just had two thoughts in quick succession. One thought might be extend to some point F here. I'm pretty sure we can extend these lines up and they'll meet at some point F. And then we'd have this triangle here similar to the big triangle. But that doesn't really get me AD. But it's still a thought, and then maybe I could use power of a point with F or something like that. So that was a thought that just crossed my mind. Another thought that crossed my mind is, what if I extended this upwards? We should still get a right angle if I extend this up, because BD is parallel to AC. So we called that O. I suppose we could call this point G. Just because I technically have E reserved here and F reserved if I want to extend AB and CD so that they meet. So line GOC is perpendicular to AC and therefore perpendicular to BD. But if a line from the center of a circle is perpendicular to a chord, BD, then it splits that chord in half. So BG is a half of BD. Okay, so that's, I guess, interesting in some way. Now, we have this 28 here. If I knew the height, the difference between these two parallel lines, I suppose I could figure out GD or BG, but I'm not exactly seeing how that would help with AD. And we always have to keep in mind that we can explore this as much as possible, but we want to look for ways to get AD. That's, I think, what's important. And in the absence of figuring out anything about E, which I think will probably be harder to figure something out about, well, I guess what we could do is translate this line and have H, so maybe say something like DH be perpendicular to AC, and then I'd get a right angle triangle. Now, CH would be equal to GD, just because I've got 1, 2, 3 right angle triangles, so we're looking at a rectangle. So then I guess I'd at least get an equation. AD squared is DH squared plus AH squared, and AH squared is at least, it's AC plus CH. So I at least have sort of a plan of attack. AC was 49. And CH, as we just said, is the same as GD. Okay, so things to think about. Oh, and DH, of course, is 28 squared minus this GD squared. So DH is 28 squared minus the GD squared. If I expand this out, I get 49 squared plus 98 GD plus GD squared. So I don't even need to know GD squared. If I could just figure out what GD is, then we can figure out AD. Okay. So that's interesting. So I actually have an equation for AD. The question is now, can I figure out GD or BD or BG or anything like that? So I'm using the 28, I'm using the 49. I've used the parallel, so I've used everything that I've been taught, or I've been told in the question at least once. But now the question is, where can we go from there? So I know that these two are the same. Now they're split up by a perpendicular line down to C. We've got a copy of this triangle over here is the same as this triangle over here. Now if I were to add in BC, I can definitely do it, stays inside the circle, but now I have triangle BCD. CG is a perpendicular to that line. And so it's an altitude, but it splits the base in half, so it would be an isosceles triangle, so we'd get a 28 here. Oh, and we've got another isosceles triangle over here. Just going to quickly write that stuff down. So, triangle BCD is isosceles since CG is an altitude and G is the midpoint of the base, although it was flipped upside down, base BD. So that tells me BC is the same as CD, which is 28. And notice also that triangle ABC is isosceles, which is something we could have noted earlier. As soon as I saw the 49, 49, I just didn't think to add BC in earlier. That's okay. Still not entirely sure that we've got something good yet, but I mean, more observations can't hurt. We have lots of plans of attack here. The AE thing might work out. I'm less confident since I haven't actually used E at all. But, you know, maybe that's a fallback. Maybe I'm going down the wrong road for the question. We'll find that out. But I could also figure out BD or GD. Any of those things will get me my AD, and that's what I'm looking for. Okay. So I got 2 isosceles triangles. Do I have any more isosceles triangles? Or any other lengths that I can work with? So, got those isosceles triangles now. This line is parallel to this line. And we already used the altitude crossing both lines to give us the 90 degrees, but we could also use a little Z theorem in here and say that these angles here, the green dots, are the same, and therefore this angle and this angle are the same. So these are similar isosceles triangles. So since BC crosses AC and BD, and you don't have to write this much. Remember, it's B4. They just want the final answer, but we're starting to move into the Part C questions, so I'm writing a little bit more. But DBC is equal to angle BCA, and from there, it's not that I'm not going to completely flesh this idea out, but triangle ABC should be similar to triangle BCD, and we know all the sides of ABC, and we're missing one side for BD. So AC over BC is the same as CD over BD. Well, that's 49 over 28, we said, and then 28 over BD. But if I figure out BD, then half of that is BG, and I need that. So we've got it. We're on the right track here. So 49 BD is, and 49 BD is 98 BG, because remember, twice BG is BD. So, but we're just cross multiplying, so it should be 28 times 28. So we get 28 squared, and now I don't even need to figure out what BG is. I can just plug it in right here. Well, BG, I guess we could say GD. Right, so AD is the square root of 28 squared plus, I think it was 49 squared, plus 28 squared. Now I can take out I can take out 49 from both of these. So 4 squared plus 7 squared plus 4 squared. Square root it. So we'll have square root of 49, 16, and 16 is 32, plus another 49 is 81. So this is 7 squared times 9 squared. Square root that is 7 times 9. And our final answer is going to be 63. Okay. So that wasn't too bad. I think we might have struggled a bit if to make the isosceles triangle connection. Because I don't think I would have thought to do BC unless I had drawn in that center there. But I wonder if extending it up like this, I have a feeling that you could do similar triangles. You could probably figure out BD from there. And all you need to answer the question is just what is BD, as long as you make a nice little right angle triangle connection here. There might be other ways, but a nice little right angle triangle there. And again, I don't think I would have made that connection if I hadn't dropped my perpendiculars from the center of the circle. So the circle geometry really kicked us off there. Started the question off. So up next will be question C1. We'll be starting the part C questions. We'll actually have to be careful as we write these things up. We will have to justify everything. So give the 4 questions in part C a try, or even just C1, and I will see you for more of the 2012 Open in the next video.